SSLC online classes for you people into our YouTube channel. Myself, Jambagi. Dear students, in the previous class we studied about linear magnification, mirror formula along with the some part of sign conventions. Right now we are trying to discuss the problems and their solutions on the concept of mirror. Before going to the problem session, just remind you that about 5 tricks I am giving back, which I have discussed in the electricity lesson. The 5 tricks I am bringing those back. So first analysis will be the first part of the 5 trick will be systematic analysis of the problem. Second one, that is screening out the problem. Then third one, searching the suitable formula. Fourth one, simplification of the problem. And last one, that is setting out the results with unit. So you need to follow these 5 tricks. By that you can easily solve any problems in the field of physics. So these are the tricks, and on the other hand we also required here to recap the sign conventions. So before going to that, you need to also read it, the sign conventions. They are very much important, as I said in the previous period. They are helpful in solving many problems in optics. So let me start the problem part now. The first problem, that is find the focal length of a convex mirror whose radius of curvature is 32 centimeter. We are calculating the focal length of convex mirror. So we have a relation called F is equal to R by 2. We have the relation F is equal to R by 2, which means focal length of any spherical mirror which is equal to half of the radius of the curvature of spherical mirror. So here I am taking the concave mirror. While explaining, we took almost time concave mirror because it is having its own importance, as we already noted that. So this is the concave mirror. This is center of curvature, principal focus F, and pole of the mirror P. As C be the center of curvature, and distance between C and P, that is what? That is the radius of curvature of a spherical mirror, and the distance between F and P is the focal length, that is small case f. So you can relate this f, the focal length of the mirror, with the radius of curvature. It is always found to be half of the radius. Focal length found to be half of the radius. Therefore, you can write F is equal to R by 2. So, you need to take that portion or that point into your mind. By that one can move to the problem easily. Okay. So, here in the problem, we are going to find out the focal length of a convex mirror. So, whose radius of curvature is 32 centimeter, given the radius of curvature R, radius of curvature of the convex mirror, radius of curvature, that is equal to R, which is equal to 32 centimeter. 32 centimeter, and keep in mind bringing conventions in. This has to be your convex mirror. So this is pole, this is F, and this will be C. So this is on positive side, radius is taken as a positive, and hence plus 32 centimeter. You need to calculate what is the focal length of that mirror. Focal length F is equal to how much? F is equal to how much? The distance between P and F, in this case F is equal to how much? Therefore, you can write, we have the relation as I discussed this. So, you can write F is equal to R by 2 and hence that is plus 32 by 2 and hence that is 16 centimeter. So, focal length of the convex mirror will be 16 centimeter. So, F is positive over here because why it is positive? All the distances are measured from pole, no doubt about that. Here in this section you will find PFC on the right hand side. That's why we are keeping this F positive and hence you can say this will be your result. Okay. The second problem, concave mirror has the focal length of 20 centimeter and the object is placed at 10 centimeter from the pole of the concave mirror. Then find or calculate the image distance. This is the problem. So just try to write and draw accordingly. Here this is the concave mirror M. So object is placed at 10 centimeter. That means that will be the object distance. So I have taken here negative 10 because it is on the left hand side. As we are already aware of the situation of conventions, sign conventions in particular. So this is on left hand side. All the distances measured left to the pole of the mirror is taken as negative and on the right side that is positive. So here the object is at left hand side and hence that is taken as negative, and focal length of a concave mirror is negative because that is also on the left hand side of the origin or the pole of the mirror. So you need to calculate the image distance V is equal to how much. So this is again first point, that is systematic analysis, and this is the screening, and hence you can find the suitable formula, searching out of the suitable formula here. So we know that 1 by F is equal to 1 by V plus 1 by U. Therefore you can rewrite because we want V, keep this V on that side and rearrange the things. Therefore 1 by V is equal to 1 by F minus 1 by U. Therefore just simplify this, by that the solutions and the simplifications become easier. Okay. So 1 by V, which is equal to sending this U on this side, F on this side, you can write U minus F divided by Fu or UF, no problem. So on denominator Fu you can write or UF, no problem at all. Okay, just shuffle the things by cross multiplication. You left out with V is equal to UF divided by U minus F, which is equal to U is minus 10 centimeter and F is minus 20 centimeter divided by U is again minus 10 minus of, that is minus 20 gives you plus 200 divided by minus 10 plus 20, which is equal to V 200 divided by 10. Therefore V is equal to 20 centimeter. Now you got V is equal to 20 centimeter. So since you got the result of image distance in positive, you can easily predict that the image should be behind the mirror. Behind the mirror, that is 20 centimeter. That's what it means. If it is negative, then the image should form somewhere here. So that's why the conventions are very much important. I hope you got all these things right. An object is placed in front of a concave mirror. In front of a concave mirror, an object is placed of radius of curvature 40 centimeter. So we have the concave mirror. In front of it, we have placed the object that is having the radius of curvature. The concave mirror is having the radius of curvature 40 centimeter. An object which is placed at a distance of 10 centimeter. Object is kept at 10 centimeter, and the radius of curvature of the concave mirror is 40 centimeter. Find the position, nature and the magnification of the image. You are calculating the image distance, nature of the image as well as the magnification of the image. So let us try to write those. Again, this will be the systematic analysis as I mentioned. So this is the systematic analysis of the problem. Whatever the problem given, you need to analyze that problem systematically. So second step, that is the screening. Therefore, I drawn a concave mirror M, and all the procedures to draw the concave mirror, you need to follow that. So here, this will be the concave mirror M. We plotted the pole of the mirror P, principal focus or focal point F, and center of curvature C. Therefore, the distance between C and P will be our radius of curvature, and if you keep the object at somehow 10 centimeter distance, that will be the object distance given as per the problem, and you need to find out the image distance along with the nature as well as magnification. They have mentioned the radius of curvature. They did not give the focal length of the object. That's why you need to calculate focal length also along with image distance as well as the magnification. Okay, so let us try to screen them. So given parameters or given data are as follows: radius of curvature R, which is equal to 40 centimeter. Now the question arises whether it is a 40 plus or minus as per the rules of sign convention. So R should be, that is minus, because you are taking the radius of curvature from left hand side. As I already quoted that RHS should be taken positive, LHS should be taken negative. So that rule is being adopted here. Therefore, R is equal to minus 40 centimeter. This is very much important. Tracing out the sign convention is very much important. Please take care of those things. Okay, so radius of curvature is taken as 40 centimeter, and object distance U, that is given again, that will be equal to that is 10 centimeter. Again the question arises, this is plus or minus. Yet again this will be minus because it is on the left hand side of the mirror. Okay, then you need to calculate first what will be the focal length. Focal length is equal to how much? Similarly, nature of the position of the image, that is V is equal to how much? Image position or image distance you may take, and you are also calculating the magnification. M is equal to how much? So the radius of curvature given With the object distance, you need to calculate the focal length f first, let focal length image distance is equal to how much, as well as magnification is equal to how much. So the third point, searching the suitable formula here, solution. So first step, you need to find the focal length f, focal length, that is small f, which is given by r by 2, radius of curvature divided by 2 gives you focal length of the mirror, especially spherical mirror. So f is equal to r by 2, this is the formula. So you have f is equal to r by 2, and hence r is minus 40 divided by 2, that is that much of centimeter, and hence focal length is equal to minus 20 centimeter. So the focal length is equal to minus 20 centimeter. Our next step is to solve what will be the image position or image distance. Okay, to find image position. So that is, we have the formula 1 by f, which is equal to 1 by v plus 1 by u. This is the formula which we discussed in the previous class, that is 1 by f is equal to 1 by v plus 1 by u, or you may take, since it is plus, 1 by u plus 1 by v, that is also possible. We want v, therefore I am taking this as it is and sending this 1 by u on the left hand side. By that, 1 by f minus 1 by u gives you 1 by v. We want image distance v, therefore we are writing like that. So 1 by f minus 1 by u. Now substitute if you can, or else simplify this step. Okay, so I want to simplify this step. By that you can enter direct values to get the easiest answer. Okay, so 1 by v I am keeping it as it is. So sending on u on this side, f on this side, therefore u minus f divided by f into u, this is known. Therefore 1 by v, you can send fu on this side, u minus f on this side to get v by 1, or else simply v is equal to fu divided by u minus f. Just rearrange the terms. uf divided by u minus f will be our simplification for v, and hence substitute the values. U is equal to minus 10, u is equal to minus 10, and f is minus 20 divided by minus 10 minus of minus 20. That gives you v is equal to minus of minus, that is plus 200 divided by minus 10 plus minus of minus plus, that is 20, that much of centimeter you are leaving at 200 divided by plus 20 minus 10 means that is plus 10, and hence you left out with 20. V is equal to 20 centimeter. So image distance will be plus 20 centimeter. So image distance will be plus 20 centimeter. So plus 20 centimeters means what? V positive means, since we have plus v, and hence image should be behind the mirror. Image should be or image should fall behind the mirror. Okay. So we got the value of V which is in plus. Therefore, the image should be there on this side, plus 20 centimeter on right hand side of the mirror. Okay. So the third parameter, that is magnification. Now we are finding the last part, that is to find the magnification. So third parameter, that is magnification. We have two definitions, in fact two formulae. Number one, that is m is equal to h dash upon h, and on the other hand, if you write it in terms of object and image distances, it will be minus v by u. Therefore, it can be written as h dash upon h, that is the normal way of writing the magnification, height of the height of the image divided by height of the object. So here they did not give h, and hence we are not bothering too much, since we have object distance and image distances. Therefore you can write minus v by u. You take it that m is equal to minus v by u. Therefore v is we got in the previous step, that is plus 20. So minus 20 overall, minus v by u. Therefore minus 20 divided by minus 10, that much of centimeter. Sorry, centimeter is there, here also centimeter. Therefore m is equal to minus cancel each other, you left out with 20 by 10, which is equal to 2, and hence m is equal to 2, which means magnification is 2, means the image is 2 times the object. That's what it means. Equal to 2 means the image is almost, in fact 2 times the object. Okay, so just bring back this h dash upon h, which is equal to 2. That's what it means. M is equal to 2 here. H dash upon h is equal to 2 means you can write h dash, the image height, which is equal to 2 times h, which will be the height of the object. So we can conclude that the image is double the size of the object. I hope you got this problem right. With some more problems, I will meet you in the next period. Till then, take care of yourselves. Bye bye.